Okay, cool.
Well, here we are, the first 5. Or do we have more actually? Oh wow, actually we got
we have
more
more.
people. Oh hey, Tori.
Hey,
Nice to meet you.
good to meet you.
Well, should we like go around in a circle and all say our favorite color or something?
Yeah, so I kind of just introduced, I had just gotten started when you signed on, and
So I interrupted it.
no, it's okay. It was, yeah. So I just said our first 15 minutes for our agenda. I don't know if I can paste into a chat on here, but I'll just quickly talk about the agenda real quick, and then we can go from there.
Sure.
Yeah, cool. Okay. So we were thinking our first 15 minutes, 7 to 7:15, we can just do a kind of maybe semi-structured with the introductions, and then break into a chat, about maybe our favorite Clojure projects or what we're doing at work or whatever for until 7:15. And then, so at 7:15, we'll give the formal kind of Clojure-Provo introduction and what our goals are for the meetup. And then I'll do a formal introduction for Jacob. And then, now I don't realize why we have a 5-minute pause in between there, but, oh, right, because that's a 5-minute thing. So we'll do that for 5 minutes. And then at 7:20, we'll do the primary presentation from Jacob, which is a Firebase application. I don't know if there's any more that you want to add to it, Jacob.
Oh, well, I'll talk about it a lot once we get to the presentation.
Right. Okay. Cool. And then so it's perfectly planned and acceptable. We've allotted the time for questions along the way. So if anything comes up, feel free to interject and and ask a question. And we'll do this in the form of, so he's going to kind of go over a kind of an initial overview in the first 5 minutes.
Yeah.
Then a presentation on just what is the gist of Firebase, since it is all built on and on top of that. And then a code walkthrough. And then kind of throughout that, Jacob has some very interesting architectural ideas that he's landed upon, and he's going to present that. And I feel like that is the goal, the motivation of the presentation. And then at the end, we'll have a session for questions as well. And then depending on when we end that, sometime between 8:30 and even up to 9, if people have that much time, we'll just do a final closing kind of summary, a thank you, and kind of an idea of when the next meetup might be. And then we'll go into planning any next sessions. So yeah, that's essentially it.
Sweet. I'm not planning on the presentation taking tons of time, by the way, so it should be fairly concise-ish.
Cool. Okay, do we want to do a go around of introductions?
Yeah.
Start with you.
Hi, I'm Jacob, and I'm here. And let's see. Why don't we say like, where are we, and maybe like how long have you been using Clojure, and then anything else you want to say. So I'm Jacob O'Brien. I'm in Provo, Utah. I've been using Clojure for about 4 years, and that's about it for me. I'm also here with my wife, Jenny.
Hello, my name is Jenny. Support my husband, but I'm also learning a little bit closer from him.
Yep, and she's from mainland China.
Yeah.
Very cool.
So yeah, that's it for us.
Okay, I'm Brian Abbott. I'm currently up in Washington State, helping my parents move. I reside in Orem, Utah, and I've been doing Clojure now for 1 year exactly. So I love it. It's a great language, and can't wait to see what the next year, 2 years, 3 years, 4 years, like Jacob has been coding in it for, brings. So.
Hey there, I'll go next. My name is Peter. I am here in San Francisco. I am not an engineer by trade. I'm more of a product guy, but I started learning Clojure, more actually ClojureScript, about 1.5 years ago. And I'm actually an accountant by trade as well. So I find it the nested formula is very intuitive as an Excel kind of user.
Very cool. Do you plan on doing any kind of like cross-discipline projects?
Yeah, looking to launch some prototype tax apps, very exciting tax apps, hopefully using Clojure and Clojure.
Oh, very cool. What area of tax?
Tax, there's a lot of old products out in tax, so kind of connecting them all and filing with the IRS. So
Okay.
yeah, looking at that.
I used to work in sales and use tax, so it's a very interesting area.
Yeah, interesting. Talk about that later offline.
Yeah,
Thanks.
yeah, absolutely.
I can go next if so. I actually I haven't done Clojure, but I'm an Elixir developer and I really like functional programming, so just interested in, yeah, I'm in Provo, and yeah, I work as full-time as an Elixir developer. So
You run the Elixir meetup group, don't you, John?
I do, but I'm phasing it out just because I got a lot of stuff to do, and I'm not very good at staying organized. So it like comes up every month because I have it on auto. I'm like, oh, I got to come up with something, but I still do it I still do like to teach people. It's kind of one of my passions. So I just teach my coworkers because they're introducing Elixir at my work. That's why they hired me 6 months ago. And so, yeah, so I'm having fun doing that. Just like every week, I just do like a quick little, but yeah, that's enough for me.
All right, I'm Tori Anderson. I'm here in Provo. I work at BYU, and I've been doing Clojure for about 7 years, and I run a Clojure shop for the College of Humanities where we do web applications. And maybe we'll hear from Scott and Madison next. They are members of my team. So.
Hey, I'm Scott Griffin. I started learning Clojure about a year ago. I started on Tori's team last February, and we're designing a ticket support system for the CSRs in the college.
Was it Madison that you were wanting to go next?
Yes, sorry.
Oh, no worries.
I'm Madison Griffin. I've been doing Clojure for about 10 months. Is it working? And I'm here in Provo.
Very cool. So we don't much have an order in here. I think we were kind of going left to right, but if you haven't done an intro yet, just please pop in.
I'll go next. So sorry, my laptop is closed, so
No worries.
desk is kind of cluttered. I don't want to open it, so it'll just be my voice. So I'm Taylor Allred. I'm a student at BYU. This is my last semester, and I haven't done a whole lot with Clojure, but I'm a major language nerd, and I love functional programming. I have a job lined up with Bose to do Elixir as well. I love Elixir, but I have learned a lot about Clojure just reading and learning some stuff, but I haven't done a whole lot with it. So I'm excited to learn more about it.
My name's Scott, and I've been doing Clojure for about 6 months. My son's been teaching me, and I think it's fun.
Hey, and my name's Alan Whitaker. I've been doing Clojure for 11 years, and I still think it's fun.
Wow, that's awesome.
I think I might be last. My name's Daryl Brogdon. I'm in Denver, Colorado. I've been doing Clojure for about 3 months, I guess.
Cool. I forgot your name where it says the department. I'm sorry about that. You just went, but.
Yeah, I should change the label. It's Alan Whitaker.
Alan.
Yeah.
Okay. No worries.
We had lunch one time, didn't we?
Yeah. Hi, Jacob.
Yeah, nice to see you again.
Yeah, good to see you.
Where are you at, Alan?
I'm in Alpine at home, and I've started and built several companies in Clojure over the years, both here in this area mainly.
Alpine is in Utah?
Yes.
Okay. Oh, interesting. I don't know the area very well. I live in Orem, but I just moved there a
Okay.
year ago.
Yeah, we're at the north end of the valley.
Okay, cool. So it's just one question that sort of popped up in my head as you mentioned, 11 years. By far the most senior Clojurian among us. How have you seen the language, I guess, change or evolve over that time?
The core language hasn't really needed to, and of course we could trace roots all the way back right to the late 50s and Lisp and John McCarthy, but of course there are several pieces that have kind of evolved over the years. So core async being one of those, and spec coming about, and just more people using it for more things. ClojureScript was another big milestone. So being able to, because in the early years we were only targeting the JVM. So ClojureScript was a big thing, and it took a few years to where it was really practicable. But yeah, so it's mainly been in finding and adopting good ideas from other places, and the language is well suited for bringing things in right without having to modify the language itself. So most of the evolution has just been through libraries and progress that way.
Yeah, that is very cool. I looked at Lisp 1.0 and 1.5 as I was getting into Clojure, and the one thing I kind of just casually noted to myself without like actually bringing up an implementation of Lisp 1.0 or 1.5, it did seem a lot different. Now, but the one interesting thing about Clojure is the core or the Lisp languages, right? That the core, like the rule set of the syntax of the parentheses and the that kind of thing, like, and then creating the definitions and the binding was all there. And in looking at like the eBNF files for it, I think it's probably like the shortest set of syntactical definitions of any language possibly ever, which is kind of amazing, right?
Yeah, it's really cool, and it got left behind in those early decades in the sense that maybe it was ahead of the computing power and being something that was as high level as it was, and all the algol-based languages kind of took over. So when people still look at it today, it feels unconventional.
It does, yeah, very much so. It is the alien language within all of the family of programming languages. Cool.
Sweet. Well, maybe shall we just move on to presentation then?
I think we're there. Yeah. So yeah, it's 6:14. So real quick. Or I'm sorry. I'm in PST right now, guys. So I kind of, as part of our agenda, I thought it'd be nice to just sort of lay out like we're, Clojure-Provo and kind of what our goals are. Our goal, so eventually we want to get to like a regular hosted kind of a place, and then do a primary presentation once a month, or perhaps a meetup with even 2 maybe smaller presentations once a month, where we have a regular group. It's a physically located thing. And then we had some kind of greater ambitions for the group of basically having a venue for helping people come into Clojure and come into functional languages. And so that was also something else I wanted to say about the overall sort of trajectory of our group. So we are called Clojure-Provo. However, we should really think of it as Clojure-Provo or Clojure and Friends in Provo. And by and friends, what we really mean is the functional, the scientific and mathematical basis of the functional disciplines. So lambda calculus, mathematical logic, category theory, these kinds of things. So if anyone's interested in presenting on those, that's absolutely something that we feel that would be valuable for the group. And then also anything related in the functional disciplines. So Elm, Elixir, could very much find a home here, John, if you guys wanted to also bring over some of that content and members as well. We want to keep it Clojure focused, Clojure community focused, but we feel like it's helpful to gain insight from those other variances within the functional discipline. And then as a kind of almost not a secondary, but maybe a secondary primary focus of the group is to actually do like some hands-on coding stuff. So we were thinking doing coding challenges, maybe perhaps at the end of each primary meetup session, or in kind of peripheral meetups throughout that may happen on a weekly or whatever basis we have a quorum for, to do coding challenges and codathons. And so the difference being like maybe a coding challenge would be like a FizzBuzz or a string reversal or Fibonacci, just some kind of quick thing that we all collectively do together and help each other out and try to find variances or interesting implementations of it. Just help ourselves maintain skill set in maybe some other areas of Clojure that's not in our daily coding activity. And then another area kind of related to, but adjacent to that, is group-driven and group-sponsored coding. And so what that is really to either find targets of necessity within the Clojure community that have not yet been fulfilled or have not been yet fulfilled well. So that's packages, you know, maybe something like Lineagen or Reframe, a reagent, Datomic, you know, something that's a package. So if we had an idea, if someone has an idea and they want to get that going as an open source project, bring that to the group, and we can all kind of, you know, vote on it and then maintain it very methodically, mechanically, and make sure that we can keep it going together and develop it as a group. And then the other component to that is then also finding existing and valuable projects in the open source community and looking at ones that have issue reports that are either hindering them or keeping them back, and as a group kind of motivating each other and helping each other implement those resolutions and fixes, such that we can give that back to the community and, you know, hopefully have some positive impact on a global basis. And then one last thing is we do want to also kind of have a digital presence. So we're going to always try to have online, the meetup will be online as well as physical. So even though we talk about those primary physical meetups, they'll have an online component where people can at least feel that they're present. We'll have to figure out and kind of play with how that actually evolves, but that is the goal in that regard. And then we'll always store and make available both as much content as possible and the actual video sessions themselves on our Clojure-Provo website and / associated GitHub page, which we'll attach to the meeting notes after this. So I think that's it. Oh, and then I'm sorry. And then one other thing I have is the bio on, so our presenter tonight, like we mentioned, is Jacob O'Brien. And he, as he mentioned, he's been doing Clojure now for 4 years. He's also he's a solo startup founder working on finca.com, which is a cross-domain music recommendation system that he developed out of his earlier project. I forget the name, Jacob, you'll have to mention it.
So the last one was a music recommender system. Findka is not specific to music.
Okay. Okay.
Yeah, I worked on music recommendation previously.
Yeah, is it Lardam?
Lagucon.
Lagucon, okay, thank you. I'm sorry about that. Lagucon, which is available from Brew and I think also on the web. But Finca is his primary startup. And he started programming with a Visual Basic 6 app, displayed a picture of a shark eating his sister. And he likes playing guitar and taking long walks on the beach. His favorite color is black. So Jacob, take it away.
All right, thank you, Brian. That was a great introduction. All right, so let's see, let me get my slides up here. Let's see, where are my slides? For some reason they disappeared. Okay.
Sure.
Yep. Here we go, okay. Let me start at the beginning. All right, so everyone can see my slides, right?
Yes.
Okay, thank you. Thanks for the response. All right, so Clojure script Firebase. This is what I'll be presenting on. So I have recently finished working on a little application that is written with ClojureScript and Firebase, and this is basically going to be an architectural overview of it. And I'll get it. Next slide, I'll talk about why I built this in the first place, but it doesn't always have to be a why. So for now, let me just give you a little demonstration of it. So I've logged into it already. Actually, let me show you. Let's see. Well, never mind. Anyway, so this is what it looks like after you log in. And I have a couple other windows open with other users logged in, so I can demonstrate like using it. So it is a board game. If you're familiar with Clue, it's basically Clue. And the usernames are generated automatically from like your user ID, so I didn't have to deal with like people editing their usernames. And so I've compiled them from a list of Shakespearean insult words. So this is actually my favorite feature. But so anyway, with that, we're in the lobby here and we can start a game. And then if we go over here, it pops up, we can join, and let's go to the third guy. Once you have 3 users, then you can start the game. And there's a little chat box here too, so you can chat with the other users. I originally developed this on my large monitor, so that's why things don't really fit into my laptop monitor, unfortunately. But so here it is. And for anyone who has not played Clue before, it is a deductive logic game. So there's a handful of cards, and you get some cards, and then you're trying to figure out what cards everyone else has. Because the idea in Clue is that there's been a murder, and so you have to figure out, who committed the murder and stuff, and you figure that out by finding out what other cards people have. All right, so I'll demonstrate. So you take turns and you can roll the dice. So let's see, this person goes first. So, you hit the dice. You rolled a 7. We can move over here and then we'll end our turn. Whose turn is it next? Let's see. Okay, so we'll do it again. And the way, let's see, I need to roll farther before I can show you more features. But once you can get far enough to roll into the rooms, you can ask people about what cards they have. And hopefully we can demonstrate that now. Okay, so here we're red. We're going to move into the library. And then we can select a few cards. So let's say Mr. Green and the revolver. So we're going to suggest that Mr. Green committed the murder in the library using the revolver. And so we'll make that suggestion. And now if any of the other players have one of those cards, they have to show it to us. So Gore-Bellied Miscreant has one of those cards. So now over here, we can choose which one to show. And we show them the revolver, and so we can see they show us the revolver, ho ho, And so you go around like that, and when you think you have figured out which cards nobody has, because there are 3 cards that no one has, so once you figure those out, you can make an accusation, and you pick the 3 cards, and then make an accusation. And if you're wrong, like we are, you're out, and other people keep playing, and if you're right, then you win. Woohoo. So yeah, that is Clue. And that is the app which I'm now going to talk about the architecture of it. So now a little bit more background about why did I build this in the first place. So as I mentioned, I've been using Clojure for a little while. And while I love using it and I find it's great for web development, which is what I've been doing with it, it takes a long time to get up to speed with it. And so a while ago, like I'm probably a month or 2 ago, I started writing a series of tutorials to try to encode like the things I've learned about web development and my own personal approaches to it. And so this is just an example project that I was building to go along with these tutorials. I think board games in particular are actually very good for this kind of thing because They're a little bit complex for one thing. It's not just a CRUD app. You have some complex application logic in there. But also they're like multi-user applications, so you have to get real-time updates from other people. So in general, I think they're pretty good for learning and trying out different architectural things. So with that, I'm going to go into the middle section and just give a background about Firebase, which is what this is all hosted on. Before I do that, does anyone have any questions so far?
Yeah, I guess I have a question. You mentioned that Clojure took a while to get up to speed. For me, I guess I wouldn't explain my own experience that way, but it might be because I didn't have a lot of speed in anything else. So I guess what are you comparing against?
Well, I don't know if I'd say like I'm not comparing it against like a time I spent learning another language per se, but just I guess just the feeling of it. Like when I was getting into Clojure, I remember trying to just, for example, just figuring out like how do you set up a backend and set up a front end and hook them all together, and it's hard because like with Clojure we tend to have like lots of like libraries, right? We tend to favor libraries over frameworks. So it's not like with Python, you know, you just go to Django and you just learn it, right? Whereas with Clojure, it's like, oh, well, some people use this and some people use that. And I found I spent a lot of time like looking through all these lining in templates and trying to figure out like, what am I supposed to do to just hook this thing up like from scratch? And it just took a while. I mean, so I don't know, does that answer your question?
Yeah, that gives me some good perspective on my own experience. I appreciate it.
It sounds like, Jacob, you were largely referring to web development in Clojure, you know, trying to figure out which pieces you should assemble. And I'll just make a quick reference. Have most of you heard of the curse of Lisp mentioned?
Is that the IDE?
So
No.
the Lisp curse, not the.
Oh, the Lisp,
Yeah,
yeah,
there
the
is
Lisp
cursive,
curse, yes, right.
yeah. Now, the curse of Lisp, in a nutshell, is just that because of the power of it, a lot of people feel like, I'll just write my own of each thing. And so because things are so accessible, everybody does their own, and sometimes it's hard to get momentum behind a particular, you know, choice or library that becomes a common place for people. I think in web development and Clojure, Reframe has maybe been the closest to that, but you know, and even then there's quite varied solutions to doing web development.
I'll just plug in here. So I also got started in Clojure with web application development mostly. And the thing that made it just take off and just start out exciting for me was I started with the book by Dmitry Sotnikov, Web Development and Clojure, which introduces his I guess it's a library, kind of a framework, Luminous. And it's pretty much a one command and suddenly you've got a working web app. So I guess I kind of jumped over that problem.
So Tori, does Luminous, well, okay, I should say, doesn't the reagent reframe stack, I believe, builds on top of Luminous, and that Luminous was really, it's a middleware oriented web server architecture implementation. Is that accurate to say? Or?
Not quite. So I started Luminous long before I knew about reagent and well before I knew about reframe. Or yeah. But so Luminous is really just a curated set of packages put together in a way that makes a web application work. So it has middleware stuff that makes sense, and it has routing stuff that makes sense, and you can optionally tell it what database you want to use and what front end. If you want to use reagent, if you want to use ClojureScript, you just tell it which ones you want, and it provides you with a fully built directory with all of the packages you need for that.
Very cool.
Sweet. All right, well, let's move on to next bit. So Firebase. So Firebase, like, just a quick like overview. I don't know how familiar people are with Firebase or not, but it's basically like a mini version of AWS. has like a much smaller scope than AWS, but tends to have a much better developer experience. And I find it's quite good for, you know, like just like early stage projects, just getting them up and running, which is, you know, as a startup founder has mainly been the area I've been focused on. So anyway, so with Firebase, this project is using 4 parts of it. So there's hosting, which is pretty simple. You know, they just host the static files for you. Authentication, which is a drop-in authentication solution. It handles signing in with emails and SSO providers like Google, Facebook, etc. And then Firestore, which is the database. And then Cloud Functions, which are, you know, like AWS Lambda functions, so you can run a bit of JavaScript code on the back end. So hosting and authentication, there's not much to those. Pretty simple. But Firestore, just to give a little overview of that. So like the rest of it, the nice thing about it is just very little setup required. It's all managed for you. Another big thing is to have a rules system. So instead, like normally with a database, you would, you know, set up endpoints for, so whenever you want to read or write some data, you set up an endpoint on your backend and then you call the endpoint and then it gets some data out of the database for you and sends it to you. With the rules system, you have a file where you specify things like, you can say like anything in this table can be written to as long as the user writing it has like this property or something. So you can define this set of rules, and then Firebase will just authorize requests for you automatically, so you don't have to deal with going through any endpoints, which is fairly nice. Another nice thing is the data model is fairly flexible. I was originally somewhat turned off to using Firebase's database because I thought it was mainly like a denormalized database. I know like their original one was basically just a hierarchical JSON document. But getting into Firestore, I found it actually is idiomatic to store normalized graph data in it. So I found that like data modeling is not really restrictive in it at all, which is quite nice. And then of course, subscribable queries were the original big feature, which is the idea, you know, you can specify a slice of the database that your client application is interested in. And then whenever anyone writes to that bit of the database, excuse me, you will get an update to the client. So you don't have to write any logic for like, okay, when I write to this part of the database, I need to go out and notify this person and this person and this person so that they can keep their state up to date. So it can simplify some logic. And this is one of the major features I've used in this app that I'm demonstrating now. So we'll get to look at that a little bit. Some of the cons are, main thing is that the queries are quite restrictive. You can't do joins. So like basically all you can do is say, like you can only retrieve things from a single table at a time. So if you have a table, like in this case, we have a table for all the games. So when you first log in, you're going to see a list of all the games that people have started that you can join. So you can only do like a single query to get all those games. But then after that, you would have to do additional queries if you wanted to get other data, like what messages people have sent in the chat room, for example. Whereas in SQL or data log, you could just basically write a query to get it all in one go. Let's see, other things is the rules system is a little bit inconvenient and somewhat frustrating to use, but you know, it's whatever, you can get through it. So I also think like in Clojure, I think we could do a little bit better with spec anyway, because like spec is really good at checking the shape of data, which is an important part of authorizing writes to your database. And I've done a little bit of that in the past already using spec to like automatically authorize writes based on a rule system. So whatever. Hopefully, maybe we'll rewrite Firebase using Clojure sometime. And then of course, it's just not datomic. You know, you can't time travel on things. But for some app, it matters. For a simple app like this one, we don't really need any of the datomic specific features. So it's been all right. All right, so that's about it for Firestore. Oh yeah, I also have written this library, which I released a couple weeks ago. And it's just a wrapper around Firestore. And it also demonstrates a little bit like what it looks like to model data in Firestore, which is nice. So here's an example. Basically, like on the left here, the key, this is an ident. So I've kind of stolen this from Fulcro, where they have the first element is a keyword that specifies what the table is that you're writing to. And then the second one is just the ID. And then here we can pretty much just have an arbitrary document hash map. Firebase doesn't enforce schema on you, so you don't have to say like the users table has a name column that's of type string. You don't even have to define the users table at all. You just start writing data and there it is, for better or for worse. So let's see, and then over here on the right, this is an example of what it looks like to query for the data. So like if we wanted to just get a list of all the users, this is what we would do. So this is an ident, but we've just left off the little ID here. So it means just everything. And this is actually a shortened form for this one here, the hash map form where you set ident. And if you do the expanded form, you can add where clauses like this. So this is fairly obvious. We get all the users who like tennis, right? And that's pretty much it for querying. Let's move on. So the last bit of this section, cloud functions. So this is what Firebase uses to let you write backend code. And there are several uses for them. In this project, mainly what I've used them for is for authorizing rights that are a little bit too complex for Firestore rules. I find that the rules system works really well for CRUD operations. And that's mainly where you need it, where every time you want to add a new piece of data, you don't want to have to go update all these endpoints, right? So rules handles like simple things like that, but with this, for example, like a board game, you have a lot of more complicated things like state transitions, and you have to do certain actions for the user. Like when they're rolling dice, you can't let them just choose how much they roll and give it to you. You have to generate a random number on the back end, which is not possible with just the rules, right? So for those kinds of things, you have to set up a cloud function and then just have the front end call it like a normal app. And of course, they're serverless, so they're fairly easy to manage, which is nice. Downside is it's just nicer to use Clojure on the JVM. And also one thing, at least out of the box, I found I was not able to inspect state from my editor, and it kind of makes sense because the whole, like normally with a Clojure backend, right, you might set something up. If you have an endpoint you're debugging, you could write a line of code that would capture the ring request object and save it to memory, right? And then you could, connect to the REPL through your editor and see what's in the request and do things like that. But with cloud functions, the whole point is that, you write a bit of JavaScript code, and then whenever a request comes in, you spin up the function and then handle it, and then, maybe it stays around for a little while, but then it might get killed, right? So it's ephemeral. And so I found with the editor, I was not able to capture those requests, which was a little bit annoying, but you can always just use print statements, which is what I ended up doing, and it wasn't horrible for a simple project like this. So yeah, my overall thoughts about Firebase is that hosting and authentication are super awesome, and I'm planning in general to use them just as default for all my projects. And Firestore and functions, I think, are very nice also, especially for just getting something started in the early stages without spending a bunch of extra time managing infrastructure. But of course they have, some caveats, so you need to just think about it. So that's Firebase. Anyone have questions before we go on to a code walkthrough?
Is Firebase free, or is it subscription, or how does that work?
So they have a free tier, and then it's pay as you go. the free tier is quite generous. So like I'm running my startup on it, and granted my startup has about 10 weekly active users, so it doesn't have a whole lot of load, but you can get fairly far just on the free tier, and then after that, pay as you go. They have a little calculator too, so if you know how much load you're going to have on an app, you can like move little sliders and see how much is it going to cost. But yeah. All right. Any other questions?
I guess, Jacob, with the authentication stuff, like, so in the past I've used Buddy. Was it somehow, did you integrate it with Buddy, or what was your approach? Or did you just use the Firebase Firestore authentication kind of raw?
Yeah, so you pretty much just use it raw. So the way it works is like you don't have to like touch passwords or anything. Like you just drop in some code on the front end, and then they will use that to authenticate the user in whatever way, and then they will store a JWT, like a little token, right? And so then what happens is on the front end, you store that token, and then anytime you send a request to your backend, you include the token in the authorization header. So using it from the backend, what it looks like is you just take the request object, you pull the token out of the authorization header, and then you decrypt it. And then it will include a user ID. And so that UID is what you use for authentication. So you store it in your database and stuff. Does that make sense?
That totally makes sense. I'm just trying to think about how that, so you do that manually or at some point in your pipeline, you're doing that as part of each request.
Yes. Now, actually, if you're totally just using functions, you don't even have to do that. Like with both like writing to Firestore and calling Cloud Functions, they integrate, like both those things integrate with authentication. So you don't have to handle that at all. Firebase will handle like including the token and then also parsing it out of the request for you. But so for example, all my previous projects, what I was doing is, I was using authentication, but I had a regular like Clojure backend on Datomic. And so in that case, what you would do is then you would write the code to like include the token with all your requests and then parse it out.
Yeah, I feel like that's something I would love to see sometime, because authentication is something I've never really solved yet. So
yeah, I have a lot of code lying around. I could throw together a little example of just the authentication sometime, because I do feel like when I was first starting, like getting into authentication, trying to figure out like, okay, should I use Buddy or a friend or whatever the other one? I was like reading these Clojure tutorials, and I was like, this seems like really complicated. I mean, it's not horrible, obviously, but it just seems somewhat tedious. But like eventually I found Firebase authentication, and I was like, why isn't everyone just using this? It's just, you just don't even have to think about it, which is super nice. Sweet. All right. Any other questions before we go on to code walkthrough? All right, let's do it. So mystery cows. I didn't show you the landing page because I forgot I was already logged in. In fact, actually, let me just go back and now sign out, because I was really proud of this. I took Clue and I made it cow themed. So I've called it Mystery Cows and got all these pictures of cows and stuff. I was gonna rename the cards to all be like cow names, and like the weapon would be like a cowbell or something. But I realized if I did that, then it would be a little bit confusing for people who already knew about Clue. But anyway, so that's why it's called Mystery Cows. We'll go in a second. But this is a little diagram of all the namespaces on the front end. So I've called it the pentagram organization, which I've been using for my projects. And so these three will look familiar, probably. Like in Reframe, this would be like events. but you know, we have a DB namespace that has like an atom that we store all the state in, and then we have some reactions based on that. So we denormalize it. And then components I'm using rum for generating React components. So we'll take the DB and generate React components from that. And then mutations. So reframe has like a event handler, right? So you trigger events and then it'll do it for you. With this, I've done it a little bit simpler. I just write a bunch of functions that swap on the atoms directly. But what I have done is I've set this up with dependency injection. So rather than like having components depend on DB and like mutations depend on this and components depend on mutations, they all define a hash map with all the contents of that namespace, and then core pulls it all in to an environment variable and then passes it around, which I'll demonstrate in a second. It's for a simple project like this, it doesn't really matter, but it felt a little bit clearer to me. Anyway, these other two namespaces, so util is just, it's like application logic, basically. Just anything that's not really tied to these things specifically is put here. Excuse me. And lib is pretty much the same, except lib is for things that are not even specific to this project. So it's a staging ground for code that I want to pull out of the project and put it in another library. So I have another GitHub repository called Trident, which is just a bunch of projects, and all the code that I write in these various projects and pull out of them, I just stick them in Trident so I can share them easily. So we'll see a bit of that. Anyway, let's go to GitHub. So this is a repository. And by the way, as of today, I added some setup documentation here. So like I mentioned, the whole point of this project is to help, I mean, kind of like Luminous, like Tori was saying, it's just another example of something that will help you to just get a running app up as soon as possible so you can start fiddling around with it. And this is just like a version of Luminous, but based on Firebase instead. So if you just follow these steps, it will you'll set up like your own Firebase project and provision everything necessary, and you can like run it on your computer and also deploy it and have it deployed without necessarily knowing anything about Clojure or Firebase. So let's jump into it. Source. So this is the folder. In total, it's about 1,300 lines of code, so not a whole lot. Let's start. I'll just show you this one first. This is what I use to generate the HTML files, by the way. It's using rum server-side rendering. So
what is rem again, Jake? Oh.
Rum is a React wrapper. So like reagent is the most popular one, right? And rum is another one that was written by Nikita Prokopov. I think that's what his name is. And it's basically like a lot simpler than reagent. Like reagent includes a lot of extra stuff that rum doesn't, like reactive atoms mainly. Whereas rum is a bit more low level. It's like a pretty thin wrapper around React. I think the GitHub page says it's about like 900 lines of code. For simple projects, they're honestly not that different. I like rum, it just feels better to me, to be honest. I wouldn't say there's a huge difference in my actual usage, except that I was never able to figure out how to do server-side rendering with reagent. I know it's possible, but I just never could find an example, whereas rum is very easy to do server-side rendering, so there's a plus.
What is the rem GitHub, just real quick, sorry?
Rum GitHub? Sure. How come this isn't letting me start a tab? Oh, Zoom is in the way. Okay.
I searched for it on Google, but of course, the name rem is.
It's rum.
Oh, rum. R-U-M.
Yeah, so we're doing rum. So it's Tonsky rum.
Got it. Okay, right on.
So that is rapid eye movement in Clojure. All right. So we generate all the HTML files with this, and here's a little example of how we tie in the Clojure script code. So this is the file that is generated by Shadow Clojure script, which is what I'm using for compilation. which also is a very great project. If you haven't tried Shadow, you should try it out. So now the rest of these files are the front end. So here's that core namespace I mentioned before. And so basically, like mainly what this does is, it pulls in, so components, DB mutations, and then it takes these environment maps that I was talking about and packages them all into this little env variable here. And then we pass that around. So like there's a mutation here, for example, and we include env. So then the mutation can get to the database atoms through there and swap on them. And same thing here with rem, we mount the component and we pass an env. And in the components, basically that env map, we just pass it down the call stack. And so like, let's see, let me go to the, so turn controls is a good example of one of the components. This is, oh, dang it, I logged out. This is like, so this component right here, it says like roll the dice, or it'll show something else depending on what like state you're in. Like right here, it just says waiting for this person to do something. So that's what turn control is. And so like the argument it takes is right here. And so all the keys are namespaced. So all the data things are under db/keys. So we can get the denormalized data. Like here's an atom that says like, is it your turn or not? Or what state are we in? And then mutations for like rolling the dice. So like say if we're in the start turn state and it is your turn, then we're going to show this button. And if you click on it, we'll call the roll mutation and pass along the env. And that's basically it. Like if you've done front end Clojure script development before, there's not really anything super earth shattering here. If you haven't used rem, it's a decent example of that. So let's move over to mutations. And these are also fairly simple. So like the roll dice, for example, here's that roll dice mutation. Like all it does is calls handle. So the handle, fn/handle is a cloud function. So this is an example of before I was talking about for some of the writes, we just pass them along to the backend. And so that's what we're doing here. We have like a reframe style event where we have like the name of event and then we tell like what game are we a part of, right? And that's what most of these events are actually. I probably could have abstracted these into a single function or something, but just haven't dealt with it. For other ones, like when you send a chat message, that's simple enough that we can just use Firestore rules instead of going through the backend. So here's like an example. We're writing to the messages table and sending along the message text. So yeah, that's about it. There's some more interesting stuff here that I want to get to about like setting up subscriptions, but I want to get to the database code first and then we'll come back here. So db.clojs, this is where we store, so we have db and atom, and this is our, our entire database is stored in here. And then we have some cursors and derivations. So a cursor is just like a pointer to a specific path in this atom, right? So we have like the user's email and the user's user ID. Derivations are like reactions in reagent, yeah. So these are two macros which I have written that make the syntax a little bit more concise. But basically, like here on the left, we're defining atoms, and then on the right is just an expression that uses some other atoms. And whenever the dependency atoms change, these will stay up to date, right? So like here, so data, for example, I won't go into exactly how this is happening yet, but data will hold our normalized database. So it's going to be a hash map, and the keys in it are going to be tables. So for example, like here, games and messages, we're just pulling the games table and we're pulling the messages table. And so now games, like this thing is going to be another hash map from game IDs to the documents. And you can technically nest data, but I don't really do it that much. So it's fairly flat and normalized, which is nice. And then we define just a bunch of other stuff here, right? Like finding out which, like the current game. So we go through the list of games, get all the values. So we're leaving out the game IDs and just getting documents and finding out which one has the current user's ID in the player's field, right?
So is this sequential so that when something says data is referring to the data that was defined above it?
Yes.
Okay.
Yep. Yeah. And that's part of what this macro does is, so normally like this is under the hood, it's using rum's function for making derivations. And in that function, you have to pass explicitly the atoms that are being depended upon for that expression. The way I've set up this macro is, first of all, we can give it a list of atoms from up above. So these can come from anywhere. So we've defined UID and subdata already. But then after this, what happens is the macro will take an expression like this, and then it will traverse the code and find all the symbols. And then it will look at the symbols and say, are any of these symbols in this vector or defined previously? And if they are, then it will replace those with the value in the atom. So like games here, we'll see is defined here, and UID is defined up here. So then it will set that up for you.
That's very cool. Something, you know, I'm lousy with macros. I almost never write them. And so I love examples like this that show why the macro itself is useful instead of just a function.
Yeah. It took me a while to get into macro. Like I had been using Clojure for, I don't know, like 2 or 3 years before I really ever wrote a macro. And I remember trying, so back when I had a job, of course, I was always, you know, proselytizing the virtues of Clojure, right? And I was in a discussion once with my coworker and trying to explain like why macros are good. And looking back on it, like I honestly didn't really know why they were good because I'd never really written one. But like, I don't know, at some point it just kind of clicked and I realized like, oh, it's just a function, but it takes like code instead of data. I don't know, yeah.
It's a tricky.
So
if I could chime in.
Yeah, go ahead.
Yeah, I didn't really understand macros or like the like virtues of macros until reading about them in Elixir. And it really kind of struck me was that the language itself, and this applies to pretty much every Lisp as well, because Elixir is very much in the tradition of Lisp. Like the language itself is built from macros. Like you want to do an if statement, that's a macro. You know, it takes a block that will run, and it will also take it. Basically, it takes your code and brings it down to AST, and then will work with that AST to create new code at compile time. And so, basically, the idea of macros is like you're expanding the language itself, and that's pretty dang cool, and also kind of scary too. So.
Yeah, now when I try to explain them to people, I usually say like think about like any feature that you would have to wait for the language maintainers to write. So for example, like in JavaScript, say like you wanted like a dot operator that wouldn't throw an exception if you were using it on a null, right? Like some languages like Kotlin have it. So you can do like foo dot question mark dot, let's see, foo dot question mark bar dot question mark baz. And then if like any of those things are null, the whole thing will just be null, right? And like a JavaScript, you'd have to wait for the language maintainers to implement that kind of feature. Whereas in like Clojure, you just add it yourself, you know?
Yeah, it's a beautiful thing in Clojure. I think that the culture has been a little bit conflicted about them because another of the precepts of Clojure is simplicity. That's one of its defining things. And macros usually throw a wrench in simplicity.
One thing I was thinking to myself as I was looking at this, Jacob, it's so clean, you know, it's so clean. it's a really good demonstration, I think, of a perfect implementation or perfect use of a macro. You know, you took it all and just cleaned it up and put it in one little thing here. And kind of, I guess what we've alluded to in this sub conversation is like, there is some complexity that you have to know. And it feels like that could mess you up if you don't know about the derivation structure, I guess. I'm assuming it would. But it's neat just how simple this is.
Yeah, and something to note is that, yeah, like the first rule of macros is don't write macros.
Yeah.
A lot of that has to do with the fact, well, because like basically what we've created, or what this macro is it's a DSL. It's a domain-specific language. Because you can abstract your code using functions, and that's the Lisp kind of way. It's all about abstraction. But then you go up another layer, it's the language abstraction, and that's very much like the Racket mindset, is that once you have a set of operations, you go up one level and you create a language of those operations. And so I think that definitely makes it hard to reason about and loses a lot of the simplicity and the kind of purity of the language. But I think the problem is less the macros and more about how we reason about them, because when it comes to say like a function, we can usually reason about that and say, okay, here's where it comes from, here's what kind of things it takes as arguments, here's what kind of things it returns, and we can kind of expect things from it. And if there was a better way of notation perhaps then for macros, then maybe we could reason about them better, but I'm just kind of dreaming about that.
Yeah, it's an interesting idea. Cool. Well, anyway, maybe let's move on to the next section. So this last bit, the subscriptions part, is like my favorite part of the whole app. It's like the little cherry on top. So what this does, because the thing we haven't covered yet is how does data get into this atom in the first place? Right, like once it's there, you have all these derivations, right, that are going to denormalize it for us. But how do we get it there in the first place? And this is basically how. So we have Firebase queries, right? So we talked about those. We can write a handful of different queries to subscribe to things in the database and then get notifications. But the problem also is that in some simple situations, you could just at the beginning when your app starts up, you could just subscribe to a bunch of queries, and then, throughout the whole life cycle of the app, those everything it needs is there and it'll just listen to those queries for the whole time. However, there are a couple problems, basically two problems with that. So one, depending on what state your application is in, you need different data. And maybe at the beginning it doesn't matter, but eventually your app will get to the size where if you're subscribing to everything, it's going to be too much, right? So for with this example, if you're in a state where you have not joined a game, then you need a list of all the games that have not yet started, right? Whereas if you're already in a game, then you just need information about your game, but you also need extra information like the messages and things. And that actually brings us to the second problem, which is in this app, you also can't, at the beginning, you can't just give a list of all the queries, because at the beginning when you have no data, you don't know which game you're in. So you don't know which messages do you need to subscribe to. So if we had SQL or data log queries that we could subscribe to, we could write a query that would do joins. So in one go, it could figure out, what game are we in, and then also get all the messages for those games. But for Firestore, since the queries are more restrictive, we have to do it in multiple queries. But this is a way that we can sort of get around that. We can declaratively do joins on the front end and do all this. So I'll just explain how it works finally. So this is another derivation, and it is a set of query objects. So I mentioned a little bit before about trident.firestore. And so these are all things that we can pass to that library and it will subscribe to Firestore queries with them. And so since it's a derivation, we can take the entire state of our current app and then have the set of queries we're interested in be derived from that. And I've set up some code that will put a watch on this atom. And whenever it changes, it will automatically subscribe to any new queries and unsubscribe to any old queries. And then it also handles like taking the data that comes in from those subscriptions and then merging them into the database atom up here for you. So with all that stuff in place, like defining what data your app needs is totally declarative. Like you just set up this thing. So to dig into it, like here we're saying if game ID. So this means like, are we part of a game? If not, then we're going to subscribe to these queries. So we're going to get the list of games where the current state is lobby. So it hasn't started yet. But then we're also going to get the list of games that contain our user ID. And that's because, say like you load the app, you join a game, and then you close the window. If you open the window again and load the app, like when it starts, you're not going to have anything in the database. But that doesn't mean you're not actually part of the game, right? So this query will check to just see like, are you already part of the game? And if you are, then like on the first run of these derivations, right, we'll go down this branch, we'll do this query, we'll get that data, we'll find out that you are part of the game. And then this game ID is up here, right? So this will automatically be updated by the derivations. And that will cause subscriptions to change. So now we're going to subscribe to this list of queries. So these queries will automatically be unsubscribed to, and the data that came from them will be garbage collected for us. So we don't have to worry about like throwing out data that we're not interested in. And now we're going to subscribe to the specific game that we're in, and like all our cards, and then like all the messages, the events, and some other information about like who showed us certain cards and things. So I'm very proud of it. I hope you all like it. But let me go over to, because the way we set that code up is actually, it goes back to here. So core, when we load the app initially, we call this initdb mutation. And that is right here. So what this does is, so first of all, we're getting the subscriptions. So there's that atom we were just talking about. And we're going to do some initial things. So so by the way, little side tangent, this is this user object comes from Firebase authentication. So if you were wanting to get the user token and send it to your own like Clojure backend, you could get it from here. But we don't need to do that. So we're just pulling a few bits of data out of it and swapping it into the database. But then we call this maintain subscriptions function. So it's in the lib. So I haven't pulled it out yet, but I'm planning to pull it out into a separate library. And we pass it two things. So first is that atom that contains all the subscriptions we're interested in right now. And then there's a function. And what this function needs to be is it takes a single element from this atom, so one of those query objects, and it returns an async channel. And so that channel represents the subscription. So whenever new data comes from that subscription, it'll come on the channel. And so this is actually not tied to Firestore at all. Like you could, if you set up your own sort of subscribable query system, you could, and just wrapped it in core async, you could throw it in here too. Anyway, but we do use Firestore, and so subscribe here, we've defined this one that will, call Firestore subscribe. So this is another, let's see, yeah, so this is another function from that library I wrote, which will take the query and then return a channel for the Firestore subscription. And then what merge subscription results does is it listens on the channel. And whenever anything new comes in, it will swap it in to this atom, which is one of our, derivative, well, not a derivative, it's one of the cursors that we can swap stuff into. And it will also handle, this is what handles the garbage collection. So when a subscription is closed, we just close the channel. And so here it'll listen to any closed channels. And then if it's closed, it'll get the portion of data from that subscription and dissociate it from the atom. So it'll get garbage collected. And that is basically it for that whole system. So yep, let's go back to here. I only have like one slide left, so I'll just get through this. So the cool thing about this is, like I mentioned, is since all of that code is not strictly connected to Firestore, you could just roll your own subscription system. And especially, like, there's a lot of talk, especially if you follow like the whole web after tomorrow crowd. There's a lot of talk about, like, you know, subscribable data log and stuff and stuff like that, which is a hard problem, of course. However, with this setup, you don't strictly have to have a really complicated query system. Like using Crux or Datomic, it would be pretty easy to just set up a, like watching the transaction log. And then you could define each query as like a predicate, like a spec predicate or something. So you just, you know, you get the initial query using data log or whatever and send it. And then for new data, whenever an entity changes on the transaction log, you just apply this predicate to it and find, like, is this part of, well, I mean, you look at it both before the transaction and after, and then you can find out, like, was it part of the query before the transaction, and is it part of the query now? And then based on that, you can send some data through the subscription. And I don't think that would be super hard to do at all, which means we could like totally have like do this with a Clojure backend and use a database that's a little bit nicer than Firestore, which would be cool. And then also there has been recently a release from Materialize about SQL subscribable queries, which I haven't looked at all, and I probably won't for a while. But you could also use that to set up more complex queries. So you could like, so like on that front end, that subscriptions atom, instead of having those like little restrictive Firestore queries, you could have SQL queries in those, which would, I don't know, might make things more simple, but then be able to build your app off of that. Anyway, that is everything. So thank you very much. Any questions for that bit of the presentation?
Yeah, I've got some. One of the big things I'm always curious about is how the design process goes for you. So in the very beginning, you showed us your pentagram of kind of an outlay of how the thing shaped up. Is that descriptive, or did you come up with that in a hammock beforehand, or what's your process for building a fairly complex system like this?
So I pretty much exclusively do my development not prescriptively, whatever the term is for the opposite of that. So like building the things first and then building your abstractions out of concretions, right? So like the pentagram thing, I did not start this app out that way. I just had mutations, like depending on the DB namespace and things like that. And then because I find like I really like to just look at the code visually. I find like it's very hard for me to like beforehand just sit about something and think, how do I want to architect this? But it's much easier like once I have the code working and I can just like look at it and try to find patterns and set things up that way. So does that make sense?
Yeah, I like that. There's a back and forth in that comes up a lot of my discussions in Clojure, because on the one hand, you've got the REPL-driven thing where Clojure is, like a lot of lists, really good at grassroots, bottom-up kind of agile development. And on the other hand, you have the traditional software development and test-driven development and maybe even hammock-driven development, where you really do a lot of thinking beforehand and you really try to solve or formulate the problem in a different way. So it's a little bit of a tension right there. And so it's cool hearing how you approach it.
Yeah, thanks. Let me stop sharing my screen too so we can see each other. Any other questions?
I guess Jacob, so I guess would you say your main kind of like architectural sort of discoveries in this are, it looks like it's the sort of essentially what you built off of the concepts of derivations in RUM, and then you package them as Clojure macros.
Yeah, I mean, I would say like specifically the main thing with this project is using derivations for defining what subscriptions you have. That's an idea that like popped into my head about 1 week ago. And I thought, whoa, like I could do this. And that's why I started working on this, because I couldn't think about my startup anymore.
Right.
Until this was done.
Okay.
But yeah, derivations, I mean, I guess the macro for doing them concisely is like somewhat new. I guess I don't know. I
think it is. I mean, and that's the thing. What the thought I kept having in my head, and I didn't know that I was understanding what you were building accurately enough to make sure that I was certain about the reaction. But it was like, you know, compared to my familiarity with reagent and reframe, and kind of what we built on that, you know, with the subscription model and the RADA model. It's very easy in that for it to get disconnected and decentralized, and for you to not know what you have where, and for that to cause, truthfully, like kind of latent bugs later on down the line that you just don't even know are there until you actually go to that page and put that data in and make that reaction happen. And I like what this looked like was that entire chain of that, but consolidated into one spot.
Yeah, and actually I've never actually like used reframe in Anger. Not that I'm not from the UK, but that's a great phrase. But I like looked at it a little bit and like did a little bit of stuff, but and that's kind of the reason I got into this, is that just defining, like, I don't remember what reframe calls them, but like the reactions, the materialized views, it just felt very
events and subscriptions. So you
yeah,
you call an event through dispatch, right? That's to invoke an event, and then anything that, and then you define a subscriber, and the subscriber basically attaches to a DB artifact, which is a RADM, and that has a watcher on that DB artifact, and so then that code gets invoked when you dispatch an event.
Yeah, and so, but then you can also have like derived subscriptions, right?
You might be able to. I feel like I've only know reframe at the very kind of at the shallow end of the pool. I'm sure there's a lot of functionality there that I'm I haven't gotten into yet.
Yeah. But yeah. Anyway, I think it's Domino 5 according to their documentation. They have the dominoes. Is that, and anyway, I'm pretty sure it's basically the same thing as like reactions. And what I did for a while is, for a long time, I was just using plain reagent instead of reframe. And I found out, that you can, because they have, functions for making reactions and things. And so you can build those things like just directly in reagent without using reframe. And so that's what I did for a while. And I had a similar macro that would use reagent reactions, but that would let you define them in that very like concise format. And actually it's a little bit easier doing that with reactions because of the way they're set up. But yeah, it was, I think it was like just a couple months ago, I think, that I started getting into RUM. Oh yeah, actually it was because I tried out Fulcro for a while, starting in November, did that for about 6 weeks and decided I really did not like Fulcro at all. So then I was looking into like, what else should I do? Like, should I go back to plain reagent? I just felt like the stuff I was doing did not feel super clean. And that's when I looked more seriously at RUM and then started using that. And so.
Yeah, very cool. What made you take a look
bit
at
of a ramble?
No, it's okay. What made you take a look at Fulcro?
Because I had read a lot of people talk about it, and actually it was back in June, I published an article and posted it on the Clojure subreddit, because I had built, and actually you probably remember this, it was the first presentation I gave at the old Utah Clojure meetup, and I was talking about this app I made that used Datomic and data script on the front end and let you do interesting architectural things there. And so I had written this article, and I was talking about like it'd be nice to have like some kind of web framework that did stuff for you. I don't remember exactly, but there were people who I was talking to after that mentioned a lot about Fulcro and said, oh, you should check out Fulcro because it's this great web framework and it just solves all our problems. And so I thought, okay, I should try out Fulcro, and I did. And
cool.
And it's it works really well for some people and not for me.
They had a huge presentation at the conj. So they had a booth there, like a table, and they were right in front of the two main meeting rooms, and they did a bunch of they had like not unrecorded kind of after sessions, and they had a guy from Fulcro presenting at a couple of those. And so I wanted to try it out, but I never got a chance to. But the way they described it, it looked very profoundly powerful.
Yeah, and like there has been a lot of like great ideas put into Fulcro, and actually a lot of the ways, well, some of the things about the way I've architected like this app have been influenced by Fulcro. So I'm really happy that I took that time to use it, and I think it's like super educational, just like reading through the stuff and figuring out like how are they approaching a lot of these problems. Ultimately, it just felt basically like overkill for just the simple apps that I'm building, but I would totally recommend anyone to check it out.
Right on.
Have you looked into Ohm, or is that kind of dead now, or what happened to Ohm?
Fulcro is, I believe, basically the successor, sort of. I think Ohm itself is somewhat dead, but Fulcro is like built on top of it, sort of.
That's my understanding as well. He kind of took over, took it forward from there.
Yeah.
Okay. Yeah. Well, the rule of thumb I've heard is that raw region for small apps, and then reframe is great for mid-sized stuff, and then when you're going big, you should really think about Fulcro.
Yeah. Sounds about right to me.
Hey, Jacob, can you talk about, I know you did some other stuff in DataScript first, and then now you're looking at, the Firestore, Firebase. Can you just talk about, some of the great stuff on the Firebase is easy to use. I think it's more accessible to learn, at least for me it was. DataScript, I think, is a little difficult, but it seems like it's more limited in terms of the, not the ability to have the joins or the kind of historical log. It looks like maybe the way you've designed this is to kind of have that kind of a place where you can kind of plug and play those two. Can you talk about your experience in kind of moving between those two databases?
Yeah, sure. When you say DataScript, do you mean Datomic?
I'm sorry, Datomic. Yeah.
Yeah, no problem.
Yeah,
Datomic. I've used Datomic a lot. Let's see. Yeah, the main thing with Datomic is it is a little bit rough around the edges, for one thing. Like I have lost a significant number of hours of my life to like doing stuff with Datomic and running up against bugs and stuff. Overall, it's nice, but I think, kind of like we were saying before, I think Datomic works best for like medium to large size projects, whereas like just at the beginning, even Datomic, I think is just a little bit overkill. Like dealing with AWS. I mean, dealing with AWS is the main pain point for me. I've just not used it a whole ton in my career, so I don't know, maybe if you're super familiar with it, it's not that big of a deal. But so yeah, for Firebase, that was one of the pulls of it, because for a long time I was just using like hosting and authentication on Firebase, but using a Datomic backend. I'm using ions actually, which by the way is something you should not do unless you're actually willing to pay for a production topology, which I found out the hard way. But that was a horrible experience. But basically, I just had tons of paper cuts from using Datomic when like my app was so small and like the data model is so simple, And so what happened is about like 6 weeks ago when I was rewriting my startup for like the 5th time, I thought, why don't I just try Firestore? Because I don't have to deal with like deploying to my Ion. Like every time I deployed to the Ion, it would take like half an hour because the instance was too small and it would always run out of memory. So you have to kill it and wait like half an hour for it to come up successfully, because it would like try to come up and then it would die and come up and eventually it would work. And anyway, there's just tons of stuff like from just the DevOps side of Datomic that really hurt a lot. And so I thought, you know, Firestore, it's just totally managed, Firebase, super easy. And so yeah, so I used that and it worked out great. And it was basically only after that that I got into like looking at these subscribable queries. Because then when I found out, oh, Firestore is actually, you know, you can model graph data in it quite easily. It's not that bad. So then I started looking at these subscribable queries and like using those a little bit, and then had this epiphany about, oh, we could do this subscriptions thing. And so yeah. Anyway, does that answer your question?
Yeah, very interesting. Thank you. I'm a little more familiar actually with Firebase, not the Firestore. Can you comment between why, you know, I think one is a newer kind of implementation of, they have 2 databases there available?
Yeah. So they have.
What does the one have that the other?
So basically, Firestore is just the successor. So the original one is still available. They call it real-time database, and that's sort of deprecated now. I mean, I don't know if they strictly say this is deprecated, don't use it, but they're definitely pushing Firestore now. I never used the old real-time database. I believe, though, it was mainly just like a JSON document, basically. So like Firestore now, it has, I mean, they call them collections. I refer to them as tables, right? But they have collections, so you can put your data in this like normalized fashion, and they have these queries. The queries, I don't know if they had those in the old real-time database or not. They might have, but I don't know. I think it might have just been like you have a specific path. So you say like, give me this one entity in the document, but you can't say like, give me all the people that like tennis, right? Whereas with Firestore, not only do they have collections, but they have indexes. Like all the data is indexed automatically. So all those, like the flip side of the queries being restrictive is that any query you write is very efficient. So I'd say that's probably like the main advantage of Firestore.
Cool, thank you.
But don't quote me on the real-time database because I never used it. Cool.
Cool.
Wow.
Yeah.
Anything else? If not, it's been a pleasure.
Yeah, I think we're at 8:30, so it's perfectly right on time. Amazing. Yeah. I guess, does anyone have anything else for Jacob?
Just thank you, Jacob. Enjoyed it. Thanks for your work and preparation.
No, thank you. Thank you all for coming. It's a real drag giving a presentation without anyone there to listen to it.
So, okay. Yeah, I mean, thank you guys very much for coming to and being a part of the first Clojure-Provo meetup. And hopefully it was rewarding for everyone. And we don't have our next meetup scheduled yet, but we're definitely gonna, like, it should be, you know, probably within the next 7 days. If you're subscribed to the meetup group, meetup.com/Clojure-Provo, you know, we'll try and nail something down within the next week to, let's say, 10 days at the max, and then have it scheduled for roughly around this time. So the 4th week of the month, let's call it, you know, we'll do a monthly meetup. So we'll have in April. And then, like we talked about at the beginning, if anyone would like to do kind of group coding on anything, you know, kind of staggered out through the week, like maybe let's call it once a week, we might try and shoot that gun if we have enough people available. So feel free to email myself or Jacob. And I had our contact info here that I was going to post, and now I've lost it. And oh, here it is. So I'll post this to the chat. Just feel free to contact us on this. Yeah, right there. And we'll put something together.
That still has the wrong email address for me.
I'm sorry.
It's someone's email address, but.
Right. Sorry about that. I did not update it.
Yeah. So anyone wants to present for the next one? We need someone to present. Anyway, shall we?
All right. Cool. I think that's good. Yeah. So thanks a lot, guys.
Yeah. Thanks everyone for coming, and have a great night, and try not to turn into a zombie from COVID-19, I guess.
Dude, that was good. So you think about a month for the next one?
Yeah, we think like probably once a month for presentations. Now I know like there's the Lehigh developers user group does 2 meetups a month, and they switch off. So like once a month they do like a normal presentation meetup, and then on the other ones it's just like a hack night. So you can like bring a project, or people can work on a group thing, or just coding challenges or whatever. So we could potentially do that too. If other people are down, I'd be down to do a little hack thing in 2 weeks, or we could just wait a month for the presentation.
Yeah, maybe, I'd be probably a month till the next one, but not to say as a rule, just kind of, right now it's kind of a busy time.
Yeah, totally. Yeah, I think maybe for now, we'll just stick to like once a month, and we'll just see if we get like lots of people coming regularly, then we can say, hey, maybe we'll throw another one in there.
Yeah. And Tori, like we talked about kind of at the beginning, we'll try and do even the hackathons. We'll try and have a virtual presence there as well. It's not too hard to accomplish. We live in a virtual world these days, and it's getting even more virtual all the time. So, try to make it available. If you have interest in a night where it's like, we realize it takes an hour almost, right? Or 30 to 45 minutes to make it down from Salt Lake City to Provo and then back. Like that's quite an investment on your part, just in sort of meta time, right? Or setup time. And
right.
So, we'll definitely try and keep it easy on both digital or both sort of hackathons and primaries.
Very cool. Yeah, I think one of the things about Clojure, I guess the Clojure version of the Lisp curse, is that there are so many ways of doing everything and so many choices you can make at any stage, from your development environment to the way you architect your code to the libraries you choose. I think I've never had the opportunity to really be close to the developers who are experienced. I've trained most of my colleagues and most of my teams. So it's really great to be able to see how Jacob and everyone else approaches the problems and how they use Clojure to benefit them.
No, that's a really good point. I have a project I did. It's like a sort of 100-page collection of IDE environments, development environment setups that I had it as, I think it would be a good presentation one night for the group, and then overall one of those things of sort of letting people look at it and trying things out, and just conversing on what works best and what fails the most, because it's definitely one of those things. I had recently, I had a bug in a mobile app. It was a React Native. I forget the library we use in Clojure for that, but it's React Native in ClojureScript. And it's like I use Atom, and I changed the theme. So I forget the name of it. It's this one with like the keywords are blue, or the keywords are gold, and like the keywords like def and def, def FN and that kind of thing is in blue. And man, it took me like 3 or 4 hours. I had this one little function, and finally I'm like, okay, this is just ridiculous. I cannot solve the bug. Let me like printf every little other line and see what is changing where. I had the totally wrong keyword in my function, but my eyes had like gone blind to the coloring, because it was like this light gold color. So my keywords were, I just typed them in real fast and there it is. And they didn't catch out. And it's just interesting stuff like that also, that maybe is also individualistic, but it'd be interesting to like see, like almost have kind of a watcher agent on people's computers and see like what setups statistically have the most success, and then which one, if they change from environment to environment. Because I don't know about you guys, but sometimes I just get bored of my environment and I'll switch it up. I'll switch some things up, plugins or colors or whatever. Sometimes you're like, wow, well, that actually introduced bugs in my code that I never would have thought of when I thought I'm just changing a theme. So yeah.
Yeah, I'm from the dark side where my whole life has been conquered by Emacs. So like it's literally my operating system now. But I definitely get that. And as far as Clojure goes, if you use Joker, it's just fantastic. It'll give you syntax highlighting. It'll highlight variables you don't use. It's just terrific.
Yeah, I love Joker. I use that one as well. So it doesn't catch keywords though. Does it for you? Or if I miss, that's the thing, because a keyword is not some kind of like it's not a defined variable.
Yeah, it's not a symbol. Yeah.
Symbol, exactly. Yeah, exactly. So.
Yeah, that gets me in reframe quite a bit, where I might accidentally, at some place in my application, I might have mistyped the keyword, and it takes so long to figure out where that happened and what the issue is.
Yep. Yeah. So yeah, it's interesting. One last quick side comment on that. I was a member of the Seattle RB meetup for a while when I was living in Seattle and doing Ruby programming, and this was really like a kind of a stark lesson on like the power of your environment once you get it set up right. There was one guy there who was a regular, and he's one of the best Rubyists in the world. His name is Patterson. I think it's Tim Patterson, something Patterson. But he does he maintains the Rails on Ruby on Rails stack, and the stuff he did, man, like his environment, the way he had it set up, it's like wow, everything he does is always the most performant library in the community. And like I realized why. It's like, wow, looking at his environment, the tools that he had kind of injected along the way and the reporting it would give him, it was like, holy cow, the way he did it was he had his environment so tuned and put together that it was like this factory pipeline. Very incredible. It was actually, that was the inspiration for doing the Clojure environment research project, which I'll commit that to our meetup repository, and maybe that'll be a meetup in the near future.
That would be terrific. That'd be very cool.
Yeah, cool. It's good to hear.
Another one I'd love to request, it sounds like some people have experience. Shadow CLJS, everyone talks about it these days, and I tried it recently and I had a hard time getting off the ground. So if we ever have a subject, that'd be a great one too. Shadow CLJS.
I'll write that down. Cool, thank you. Okay, guys, I think if no one has anything else, should we call it a night?
Yeah, sounds good.
Okay.
It was a blast.
Yeah, absolutely, guys.
Next time.
All right, cool.
Take care.
All right, guys. Have a good night.
Bye, guys.